We are in lecture number 3, Internet, Addressing and Security Issues. So this is network security. So what we are studying is a network security. So our concepts, our focus, everything will be based on the networks. So we are going to talk about the internet today. And also we are going to talk about the addressing concepts. And also we are going to talk about security issues in internet. Okay, so this is lecture number 3. Now, in this course, in this lecture, we are going to discuss about the 5 things: internet, addressing, address spoofing, client server model, and internet routing. So these are the concepts, the major concepts, the 5 major concepts we are going to cover in this particular lecture. Now, let me go for the first concept, internet. So what is an internet? So internet is a collection of networks. Okay, it's a collection of networks. Multiple networks are connected together. Okay, so this is the internet. Or we can say it is a collection of devices that are interconnected using the network protocols. So we are using a lot of protocols here, lot of devices, okay, and so many other devices are connected with each other. So that is going to be the internet. So we are now, okay, my system is available in a different place. Your system is available in a different place. I am in a different network. You are in a different network. So we are all connected only by using the internet. Okay, in simple form, we can say internet as a network of networks. Okay, it is a collection or networks of networks. Okay, many networks are connected together to form the internet. So some of the interconnected devices runs applications and interface with the users. Others are used to provide the connectivity between the devices and networks. So some are using some applications, some are running the applications, some are accessing the applications. We are communicating through the internet from one device to another device, from any place to any place in the world. Okay, you can communicate by using the internet. So it is a global network. It is a global network. Okay, in a very simple way, it is a collection of networks. Now, if you see the user's view, how a common user, okay, a common user is going to see the internet means a common user is going to see the internet as a black box. So he is not going to understand what is going on inside. Okay, you can see this is the user 1 and this is the user 2. So 2 users, they are sitting in different places. Okay, for example, so the first person is in Oman, the second person, so let it be, is sitting in US. Now they are simply chatting. So they doesn't know what is going on here, what is happening in this internet. Okay, an ordinary user cannot understand what is going on in the backside. So they are going to consider this as a black box. Okay, but technically speaking, okay, like you and me, the technical people, if you see, there are plenty of things are happening in this place. That means there are so many different networks available here. Okay, your packet or your data is going to cross. It is going to cross so many networks here. Okay, so it is not directly going to come. Okay, from the sender to the receiver, the packet is not going to come directly. It is not going to reach. So it is going to cross so many other networks. It is going to, okay, cross so many routers, we can say. So your sensitive data or your sensitive information, it is going to come through different networks, and then finally it is going to reach you. So in this place, there are so many threads, plenty of threads are available. You are going to send your data through an unknown network. Your data is going to pass, your data is going to travel through some unknown networks. So these unknown networks, they may be good or they may not be good. So there are a lot of threads available in this particular place. In simple way, I'm going to say this is a public network. Okay, this is a public network. So in the public network, there are plenty of threads. There are plenty of threads available. In a private network, this is a private network. Inside the private network, you don't have that much of thread. But once if you're going for the public network, so plenty of threads, okay, is going to be available. So what you understand from this slides means, if you're having the data, or if you're sending the data in your network, in the private network, your data will be mostly safe. So here you cannot find, okay, too much of threads. But if you are sending your data through internet, if you are using a public network, means in the public network, you don't know how your packet is going to come. How many routers your packet is going to cross. Okay, we don't know anything about it. So we don't know whether it is a good person or bad person. Okay, so plenty of threads, okay, available in this particular place. So this is the concept one. So we have lot of threads in the public network. Okay, so this is the thing. Now, how does internet works? Okay, or we can say internet hierarchy. Now, okay, I am the user. I'm here. You can see there is a block diagram given here, a diagram. So I am the user here. I want to communicate with another user who is sitting in another country. So can we directly connect with each other means? No, we cannot. We cannot directly connect. So what you need means, you need internet service providers. So every country if you take, there will be a bunch of internet service providers. So in Oman, we have very popular, okay, Omantel. Omantel is an internet service provider, and there are so many other companies also available. So if you go India, in India there are plenty of internet service providers. Okay, Reliance, Airtel, there are so many. Okay, so many internet service providers available. Vodafone, plenty of. Same thing. If you go to China, there will be a different, okay, a bunch of internet service providers available. So what we are to understand, without the help of internet service providers, you cannot connect. So internet service providers plays a major role here. So internet consists of interconnected internet service providers. Okay, you can see here. So this is one internet service provider available in Oman. Okay, we can take it. And this is another internet service provider available in another country. Okay, for example, take it China. Okay, in UAE, in India. So different internet service providers available. All the internet service providers are connected. Okay, so the internet service providers have an informal hierarchy in that national, international, and large regional ISPs. So they have some hierarchy. Okay, for example, if you take Oman, in Oman we have only national level. Okay, that means entire Omantel is available. So it is a national level ISP. But in India, it is not like that. In India, they have at least some 10 to 15 ISPs available, small. They are called regional ISPs. Okay, so the regional ISPs will be connected with the national ISPs. Okay, the national ISP will be connected with the international ISP, internet service provider. So they are having a hierarchy. Okay, you can see national. So national means inside a country. Inside the country, you can have many. Then international, then large regional. Large regional means like, okay, Asia, Europe. Okay, you can have some continent in the continent level. So what we are understanding from this means there will be bunch of ISPs, and ISPs, you have the hierarchy, some levels, top level, next level, okay, like that. So there will be some hierarchy will be formed. Now, so large ISPs are interconnected to create what is often referred as a backbone. So this is going to be the backbone network. So if anybody wants to connect with the internet in this world, they have to use these ISPs. Okay, so without the help of the ISPs, they cannot connect. So this is, I'm going to say it is a backbone. Okay, we can say as a backbone network. Then, so ISPs are interconnected. They are connected using the high-speed dedicated connections. So the connection between them from ISP to ISP. So a dedicated communication, a dedicated connection, high-speed connection, and this is going to carry the bulk of data, bulk of traffic, bulk of packets. Okay, they are going to exchange. So they will be very fast. The connection will be very strong. Okay, so ISP and ISPs will be connected by using high-speed internet connections. Dedicated cables will be used to send and receive the data. So this is what we are understanding this from this particular slide. Now you can see here, this is already we discussed regional ISPs, organization IP ISP. So these are all different hierarchy. Okay, organization means for a particular organization, that is a local. Then regional means a particular regional. Then you have the national level, country level. Then you have international. Then you have some, okay, some like continent level. So these are all different levels of hierarchy. Okay, levels of hierarchy will be maintained. If you see the last one, okay, that means the end, the lower hierarchy, that is going to be your organization. Then the other ISPs, like regional ISPs, okay, particular region, okay, you just take in Oman, we have different regions, okay, like North Sharqiya, South Sharqiya, okay, we have different regions like this. But in Oman, we have only one ISP. Just imagine, in every region, there is one internet service provider. Okay, for South Sharqiya, there is one internet service provider. For North Sharqiya, one service provider. For Muscat, there is one internet service provider. So they are called the regionals. All the regional ISPs will be connected with Omantel. Okay, that is going to be the national level. Okay, so depending upon the situation, depending upon the need, okay, depending upon the area, in fact, okay, you can have this ISPs concept. Okay, so this is a small introduction about the internet service provider. So without the help of internet service providers, you cannot connect to the internet. Now, I'm moving on to the next concept. The next concept is address, internet addresses. So what is internet addresses means? Here it is going to be the IP address. IP address. So where the IP address will be used? Okay, where the IP address will be used means it is used in the layer 3. That means the network layer. Okay, so IP address is a logical address. It is a logical address. We can change whenever you want. You can change your IP address. Okay, the IP address can be changeable. So we have two different versions nowadays. One is IPv4 and IPv6. We are moving from 4 to 6. Okay, we are moving from 4 to 6. Okay, because almost IPv4 is exhausted. Why we need IP address means any device in the world, any device, if you want to connect a device with internet, you need an IP address. Without IP address, you cannot connect. Without IP address, you cannot connect. So you need an IP address, a public IP address you need. I'm having a mobile phone. I'm just connecting, okay, my mobile phone with the internet. Now, without IP address, I cannot connect. From where the IP address is coming? From where I'm getting the IP address means my internet service provider, that means Omantel, is going to provide an IP address for me. Okay, internet service provider, that means ISP, the Omantel is going to provide, is going to offer me an IP address, a public IP address. So using that IP address, my mobile will be connected with the internet. Not only IP address, you need some more addresses. Some more addresses you need. So what are the addresses? We are going to see it. Okay, we are going to see in the coming slides. Different address types. You can see in the next slide, different addresses types. Okay, that we will see it later. So now we are focusing on the IP address now. Then user and application layers view of addressing. So how, okay, the addressing concept is used. Okay, now every user must have an address. Okay, every user provides address of destination computer. So that is what I explained to you in the previous slide. So without address, okay, you cannot communicate with another person. Now, okay, instead of just going for the theory, let me explain, okay, by using a diagram. You can see this diagram, so you will understand the addressing concepts very easily. Okay, now, so what is given? What is given here means there are so many applications running. So this is application 1, A1. This is the application 2, A2. Application 3, application 4. You can take it application or you can take it as a machine, a computer. Okay, you can take it as an application or you can take it as a system or a server. Okay, anything. So this is server 1, server 2, server 3, server 4, or machine 1, machine 2, machine 3, machine 4. Okay, you can take it as anything. Now, so all these things are interconnected by using the internet concept. Okay, so it is connected with the internet. Now, so anyone, okay, we have 4 users here, user 1, user 2, user 3, user 4. So any user, he wants to communicate. Okay, for example, user 1 wants to access the application 3, or user 2 wants to access the application 2. User 3 wants to access the application 4. Okay, user 4 wants to access the application 1. Anything, any combination you take, whatever the combination. Okay, if you take, so you need, okay, the following. What are the things? You must know, okay, that means source IP address. So source IP address means the IP address about you. That is your IP address. Then you must know the destination IP address. Okay, what is the destination IP address? What is the IP address of this machine? So destination IP address you must know. So source IP address, destination IP address. Then the next one is source port number and destination port number. Okay, it is coming in the next slide. So source port number and destination port numbers you must know. Okay, so source port number means the port number of the source computer, the port number of the destination computer. So source port number and destination port numbers you must know. Then source MAC address and destination MAC address you must know. So these are the 6 things. I repeat. Okay, if you, okay, this is the example. If you go in the next slide, okay, they are explaining this very clearly. So now you can see every, okay, that means this is one machine wants to communicate with the another machine. Okay, in between there are some machines available. Okay, you can see this is machine 1, host 1, host 2, host 3, host 4. There are 4 hosts available. So the host 1 wants to communicate with host 2. Okay, or host 4, let it be. This is 1 and 4. So in between 1 and 2 is, 2 and 3 is available. Okay, make it, I just repeat it. This is 1, this is 2, this is 3, and this is 4. Okay, there are 4 machines available. 1 wants to communicate with 4. So in between we have 2 and 3. So what are the different addresses? What are the addresses you need means you need, okay, maximum, okay, you need, okay, 6 addresses you need. So what are the 6 addresses? The first one is the IP address. You can follow the mouse. So you need IP address. So IP address, it is available in the layer 3. So you need the IP address. That means source IP address you need and destination IP address you need. Okay, this is point number 1. Then point number 2, I need, okay, the port numbers. Where is the port number? The port number. So the port numbers are available in layer 4. In layer 4, the port numbers are available. So I must know the source port number and I must know the destination port number. Then I need the MAC address. That is the physical address, MAC address. Where is the MAC address available? MAC address is available in layer 2. So I must have the source MAC address and destination MAC address. So these are the addresses you must have. Then only you can communicate with the another machine. Okay. So if you want, I just write it in there. Okay. I'm just taking a blank slide and I'm writing here. So okay, I'll go for the levels. So level 4. So that, sorry, not level, layer. So in the layer 4, okay, so we are having the port number. So that means for both you must have, for the source and also for the destination. Source port number, destination port number. Okay, you must have. So size, what is the length of the port number? So the length of the port number is 16 bits. We already discussed this in lecture number 1. Then in layer 3, okay, in layer 3, so we have IP address. Okay, so you must have the source IP address, and you must have the destination IP address. So what is the length means 32 bits is the length. Then in the layer 2, okay, layer 2, so we are having the MAC address. We can say MAC address, we can say it is a physical address. Okay, so there are different names available for this. So MAC address, physical address, hardware address, okay, anything. So you must have the source MAC address and you must have the destination MAC address. Okay, so destination MAC address. So these are all the address you need. Okay, what is the length means 48 bits is the length of the MAC address. So these are all the addresses that you need. Okay, if you want to communicate from one machine to another machine. Okay, from one to another. Okay, now, so this is what given here. Okay, you can see here. So this is application layer. Okay, application layer, presentation layer, session layer, all the 3 layers available here. Then the next layer is the TCP layer. Okay, or we can say is a network layer. Oh, sorry, transport layer. Okay, the next layer is a transport layer. So in the transport layer, okay, you are going to have the port numbers you are going to have. Then, okay, we already discussed this in the previous class, how the headers will be created. In lecture number 2, I think we created, okay, we discussed about the header concept. Every layer is going to have a header. So in the header only, so this information will be available. Okay, so every layer is adding. So now your data will be converted into zeros and ones. Then it is going to the intermediate computers. So in the intermediate computers, okay, up to the route layer 3, up to layer 3 it will go. Then it will be forwarded to the next. Okay, then automatically it will reach the destination. So what we understand from this means every layer is going to have some address. Not every layer, layer 4, layer 3, layer 2. Okay, so they're having some types of addresses they are going to maintain. So this is about the addressing concepts. So they are explaining the different types of addressing concepts. Okay, up to slide number 15. They are explaining this concept. Now, the next one you can see, the next one is who provides the address. Okay, who provides the address? Okay, so there is a small comparison given here. Now, I'm going for IP address. Okay, I'm going for the IP address. So if you take the IP address, you can see the source and destination. For the source, okay, and the destinations, okay, you need the IP address. Then hardware address. This is layer 2. Hardware address, or we can say it is a MAC address. So for the source, okay, and for the destinations you need. Then port numbers. Port numbers, okay, we need the source port number, we need the destination port number. Then computer address. What is this computer address means? This computer address and the hardware address is going to be same. Okay, there is nothing like computer address. For every computer, there is no separate address. Sometimes they will, okay, they will add these 2 things. Okay, IP address and port number, they will add together and they will say it is a computer address. Or they will use a name, the name of your computer. Okay, for example, www.facebook.com. This is the name of your computer. Okay, a name of your computer. So that is, we can say as a name or we can say as a domain name. Okay, this is. Then User or file address means a particular username or a particular address. Okay, or a file name, anything. But this is the three important thing. These are the three important addresses that every packet should have. Okay, every packet should have. If you are communicating with a server, means you need computer address. I want to communicate with facebook.com. So I need this address, computer address. I want to access some files from your machine. I want to access some file means I need the file address. But for the basic communications, okay, you need, okay, these three things: port numbers, IP address, and also the hardware address. Okay, so these are the very, very important concept. Okay, a very important concept. Okay, everybody, okay, must understand. Then the next one is, you can see here, they are giving here user, application, TCP, okay, IP, and network. So these are the providers. Who is going to provide the IP address to you? Okay, who can give the IP address to you? Okay, source IP address, destination IP address. Okay, they are marking it. Okay, this is not very important, but if you understand only these concepts, okay, it will be enough. Okay, it will be enough. So without this 1, 2, 3, okay, you cannot communicate. A system cannot communicate with another computer without this data. Okay, now I'll give you, okay, I'm just going to give you an overall idea again. See, my data is available. I want to send hello to this machine. Hello is my data. So the hello is available in application layer. That means in the layer 7, it is available. Then from the layer 7, it will go to the next layer, that is layer 6. Layer 6 is presentation layer. So in the presentation layer, you can encrypt it. You can convert it into a different format. Okay, you can minimize, you can compress it. Okay, you can compress it. So you can do any activities you can do. So then from the presentation layer, it is going to the session layer. So in the session layer, okay, it is going to have a connection, session ID, time, duration, all these things. Okay, when this packet is going to be transmitted. So I'm going to enter some information about the timing. Then I'm going for the transport layer. So that is the TCP layer. In the TCP layer, they are going to add a header. A header will be added. Now, what is available inside the header means source port number and destination port number will be available. I'm going to say it as a segment. Then it's going to the next layer. Next layer is a IP layer. In the IP layer, I'm going to add another header. That is a IP header I'm going to add. Then for the IP header, I'm going to add, okay, in the IP header, source IP address and destination IP address will be available. Then now I'm going to say it is packet. It is a packet. Now I'm going to send the packet to the next layer. In the next layer, okay, it is going to add a new header that is called the frame header, or we can say Ethernet header. What is available in the frame header or in the Ethernet header means we are going to have the source MAC address and destination MAC address. Okay, so source MAC address or destination MAC address will be available. Then it will be converted into zeros and ones. This process is called encapsulation process. Okay, this process is called encapsulation. Encapsulation means every layer is going to add something. They are going to encapsulate. Then the packet, not packet, zeros and ones. So zeros and ones, it is going to reach this machine. In this machine, now what I'm doing means I'm going to remove one by one. Okay, they are going to take the first header, that is the Ethernet header. It will be removed first. Then it will be given to the next layer. In the next layer, IP layer, okay, IP header will be removed. Give it to the next layer. In the TCP layer, okay, so that means the TCP header will be removed and it will be given to the next layer. Only the data will be given here. So here we are going to do encapsulation. Encapsulation in the sender machine. Encapsulation is taking place. In the destination, you are going to do the decapsulation. You are going to remove everything one by one. Okay, so encapsulation process, decapsulation process is going on. In between routers, what the in between machines are doing means simply they are going to forward your packets. They are going to forward the packets, okay, simply. So usually this will be the routers. So it will be forwarding. It is forwarding your packets to you. Okay, you can see the word internet. So this is going to be mostly the routers. So the routers is a layer 3 device. Router is a layer 3 device. So it is going to simply forward your packets to you. So this is how, okay, the things are working in the internet. So now what we are going to study, what we are going to say means this place is dangerous. So this is the place where the threat is available. This is the place where all the attackers, you can use any word. So all they are going to be sitting in this particular place. Okay, so this is what we are understanding from this particular concept. So different addresses, okay, will be used. Now, I'm going for the next concept, a very interesting concept. So what does that means? Address spoofing. Okay, address spoofing. What is address spoofing? It's a very, very basic concept used by the attackers. So attackers will use this concept, okay, a very, very basic concept. So most of the attackers, they are going to use this concept, okay, address spoofing. Okay, what is that? That means a user is not going to give the correct IP address. He is going to give a fake IP address. Okay, so using a fake source address, my address is, for example, 10.0.0.1, but I'm going to create a packet with a fake IP address. I'm going to create a packet. Okay, so this is called address spoofing. Okay, we'll have an example in the next slide. Okay, if you understand an example, so it will be very clear. Now you can see there are 4 users available. Okay, 4 users are available. So Alice, John, okay, 3 users. Okay, Mary, there are 3 users available here. Now, the address, IP address of the first user. Okay, so let it be. They are using the names. I will give the IP address, no problem. So the IP address of the first person is 10.0.0.1. This is the IP address of the first person. Now, the IP address of the second person, okay, the IP address of the second user, okay, we can say it is 10.0.0.2. Then the IP address of the third user, okay, so sitting in a different network, so you can use a different, okay, IP address 11.0.0.1 and let it be here 12. So these are the IP address. So they are all sitting in different networks. So 10 is a network, 12 is a network, 11 is a network. So there are 3 networks available here. Now, so take Alice, that means 10.0.0.1. He is a attacker. Okay, he is an attacker. Now, this person is going to, okay, give a ping command. You know the ping command. If I give the ping command, okay, what I'm going to get means I will get a reply. Okay, I'm going to get a reply for the ping commands. Now, this person, that means the first person 10.0.0.1 is going to create a ping packet. Okay, I'm going to create a ping packet. Now you can see here. So this person is going to create a ping packet. Okay, is creating a ping packet. So the ping packet, okay, this is ICMP. Okay, this is a ICMP packet. So ICMP packet means it's used for giving the ping command. Okay, now what is the source IP address? Source IP address means from where the packet starts. So the packet is going to start from me, 10.0.0.1. The packet is going to start from here. It is going to originate from here. Then, what is the destination IP address? Okay, source port number, destination, okay, port number and all I'm not giving, just to example, okay, just to explain you. Now, destination port number. Now, the destination port number is, for example, 12.0.0.2. This is, okay, the packet I'm creating. Okay, an ICMP packet. So this packet will be used just for a ping command. Okay, I created a packet like this. Now, so this person is going to give the command. What is the command? Ping. Ping. So 20 or 20, 12, 12.0.0.2. Okay, is giving a ping command like this. Now, this packet, the ICMP packet, will go to the internet. Okay, it will reach 20.0.0.2. Okay, it will reach 20.0.0.2. Now, so this person is going to read. Is going to read the packet. 20.0.0.2 is going to read the packet. Okay. So in that packet, it is written. It is written source is 10. So now this person is going to give the reply. Okay. Now he is giving a reply to me. The reply is reaching me 10.0.0.1. So if you send a ping packet, automatically you will get a reply. So this is a usual concept. Okay, this is a usual concept. But now what I'm doing means I became an attacker. So Alice, that means first user is going to become an attacker. Now this person is going to change his IP address. He is not giving the correct IP address. He is going to give a fake IP address. So now I'm giving 11. So 11.0.0.1 is my IP address. So he is going to give a fake IP address. This person is going to give in the packet. This is called IP spoofing concept. Now, what is the consequences? What is the result? What is going to happen means now the packet is going. Destination is 12.0.0.2. So which is the destination means my destination is this. So now the packet will go to the internet. Then from there, okay, your packet will be forwarded. Okay, your packet will be again forwarded to the next router. Okay, your packet will be forwarded from here to this machine. Okay, the packet will be forwarded. Now, this person, that means 12.0.0.2, he received your packet. Now, he is going to open the packet. What is written inside the packet? Inside the packet, it is written as 11.0.0.1. Okay, 11.0.0.1. Okay, it is written as, okay, the packet is coming from 11.0.0.1. Now, John is going to give reply. So to whom the reply means he is going to make a packet for 11.0.0.1. Now, so John is going to send a packet. So the packet is going to, okay, start from here. Then the packet will reach, okay, 11.0.1. That means your reply will go to this particular place. Okay, just think. You have not given any ping command. You have not given any ping command, but you are going to get a reply. So the reply is going from John to, okay, Mary. That means from here to here, the reply is going to go. So this is called, okay, IP spoofing. So what is IP spoofing means? The attackers are going to play with their IP address. Attackers are going to play with their IP address. So they are not going to give the true, or they are not going to give the correct IP address. So instead of that, they are going to give a fake IP address. They are going to insert into that packet, particularly source, the source IP address. So this is called address spoofing concept. Okay. So this is, okay, this is an example. They are not giving IP address. I'm using the IP address. Okay. And I'm writing here. So this is how, okay, the IP spoofing is going to work. So here somebody else, we don't know who is that, he is going to be affected. Okay, he is going to be affected. So randomly I'm selecting some IP address and I'm giving it to you. So this is, okay, this particular part. So this particular place, it is called IP snooping place. Okay, hope you understand. Okay, now I'm moving to the next concept. Okay, please, if there is any doubt, please you can stop me. Okay, please stop me. Is it okay? Is it clear? Shall I continue?
Yes, Mr. Continue.
Okay. If there is any doubt, anything, please stop me. Okay. Now, we are going for the next one. So what is the next one means? Host name to IP address mapping. You might have heard about the DNS concept. Okay, you already studied about the DNS. Okay, domain name service. So what is this DNS machine? What exactly the DNS machine is going to do means, so the DNS machine is going to convert, or it is going to map. Okay, we can say the correct word is mapping. So it is going to map the IP address and domain name. Okay, so what is that, teacher? So we could not keep all the names, the domain names, we cannot keep everything in our mind. So what we are using means, we are going to depend on a machine. The name of the machine is the DNS machine. So the DNS machine is going to keep all the domain names. Okay, for example, this is the domain names. So, and each domain, okay, what is the IP address? So the IP address for each domain, it will be registered, or it will be, okay, saved in this machine. Okay, for example, soor.com, this is the name of a domain. So for this, there will be an IP address. So the IP address, let it be, this is an IP address. So this IP address will be saved. Name. The next one, for example, I'm having facebook.com. So for facebook.com, so there will be IP address. So you cannot remember, okay, the IP address. For all the domains, you cannot remember the IP address. It is very difficult. But the name, domain name, easily you can keep it. Okay, even if you take our college, for our colleges, okay, we have cas.edu.om. Okay, so this is then, okay, cas.edu.om. This is the website for our college. So now for this, there will be an IP address. Okay, I'm not, okay, I don't know the exact IP address. I'm just giving, for example. So this is the IP address of our college. So what does this means? The nature of the human being. What is that? So human being, domain names, they can easily keep that in their mind. Okay, even hundreds, thousands of domain name, I can keep it in my mind. Whereas IP address, okay, we cannot. Okay, we cannot. So we are going to map it. That means we are going to have a separate machine. So the name of the machine is going to be the DNS machine. Okay, DNS machine. So whenever you want to communicate, okay, www.bankmuscat.com, I'm typing, I'm taking my browser. So in my browser, I'm going to type www.bankmuscat.com. So bankmuscat.com is the name of the domain. Okay, that is the name of the domain name. Now, so immediately my machine is going to communicate with the DNS machine. Okay, my machine is going to communicate with the DNS machine. So in the DNS machine, it is going to take what is the IP address of bankmuscat.com. Okay, what is the IP address of the bankmuscat.com? Then the IP address will come to my machine. Then my machine will communicate with bankmuscat.com. Okay, this is how the things are working. Now you can see this is an example. Okay, we are going to see the example. So what is that? See, I am the user. Okay, the user is going to type, okay, in the browser. So the user is going to type, okay, www.ibri.cas.edu.om. Okay, so the user is typing, okay, a website, a name of a site. Okay, the user is typing the name of a site, okay, ibri.cas.edu.om. Now, from this machine, I don't know what is the IP address of ibri.cas. So your machine cannot communicate. Okay, your machine cannot communicate with ibri.cas.edu.om. Now your machine is going to communicate. It is going to communicate with the DNS machine. Okay, it is going to communicate with the local DNS. Okay, we can say it is a local DNS. So local DNS means it will be available inside your college, or sometimes it may be available in your cache memory. Okay, the cache memory of your machine. So I'm going to communicate with the local DNS. So for our college is the local DNS. Now I'm going to communicate with the local DNS. Sometimes it may not be available. It may not be available in the local DNS. Okay, that means ibri.cas.edu. For this, what is the IP address? So the IP address is not available. Now, from the local DNS, you will be communicated with the next level of DNS. Okay, that is called the first level of DNS. Okay, there are some levels available. Now, suppose if it is not available, if the information about ibri.cas.edu.om, if it is not available in this DNS, then your machine will communicate with the next level. The next level is first level of DNS. Suppose if it is not available here, it will go to the root server. So what does this means? Here also they are going to maintain a hierarchical approach. So a hierarchical way of DNS, the DNS will be arranged in the hierarchical way. So they are giving local DNS, next level. So there will be a root. So finally, the root is going to be the main. Okay, you can get all the information from here. So if it is not available in the local, you are going for the first level, then you are going for the root. So this is how the DNS concept is working. So, but anywhere you will get it. So you will get the IP address of CAS, that means ibri.cas.edu.om, then you will communicate with that particular machine. Okay, so this is how the concepts are working. So what we are just talking about the networking concepts. Okay, that means the internet concepts, the concepts which are related to the internet. Okay, so DNS, how the DNS is working. What are the problems in this? Okay, what are the attacks possible on the DNS? We are not studying. We are going to cover it later. Okay, we are going to study it later. So here, just the concepts we are going to understand. Now, the next one, if you see, client-server model. So, client-server model, a very popular architecture. Okay, so what does that means? You will be having a client machine and a server machine. So the client machines going to give the request to the server machines. From the server machines, you can access whatever you can, you need, you can access. Now, what is a very important concept here? The technical concept, what you have to understand here means you must have, that means the servers must have a port number. Server must have a port number. Okay, now, if you take the port numbers, I'm not sure whether I explained this to you in the previous classes, but you can take it. If you take the port numbers, there are 0 to 65535. This many port numbers available. Okay, this many port numbers available. 0 to 65,535 port numbers available. Okay, so in this, we are dividing this into 3 groups. Okay, we are going to divide this into 3 groups. So what are the 3 groups means? From 0 to 1023. Okay, 0 to 1023, this is one group. Then from 1024 to 49151, 49,151, this is the second group. Then the third group is 49152 to 65535, 65535. This is the third group. So 3 different groups of port numbers we are dividing like this. So totally from 0 to 65,535 port numbers available. 0 to 1023, Okay, we are dividing one group. 1024 to 49151. Okay, that is the second group. 49152 to 65535. That is going to be the third group. Three different groups of port numbers available. Now, first group is called, okay, it is known as, okay, or called, this is well-known port numbers. Well-known port numbers. So they are called well-known port numbers. Now, these well-known port numbers already fixed. It is already fixed. 0 means this. 1, 2, 3, 4, 5, 6, 7, up to 1023. These well-known port numbers are fixed. Okay, for example, port number 80 means this is going to be a web server. Okay, it is going to be a web server. It is completely fixed. You cannot change it. Okay, port number. Okay, so port number 80 means it is a web server. It is already fixed. Then port number 2021. Okay, I'm writing here. So port number 2021, if you take, so 2021 means it is going to be the FTP. Okay, 2021. Port number 2021, this will be used for the FTP protocol, file transfer protocol. Then port number 23. So port number 23 is for telnet. So like this, all the numbers from 0 to 1023 is already fixed. This is well-known port numbers. It is well-known port numbers. Now, so let me just remove it. We don't need this. Okay, so that you can see it clearly. So, okay, well-known port numbers. Now, what is the point here? Okay, let me come to the point. If you have a server, or for any server, based on the service, what this server is doing, based on the service, you have to assign a port number from this particular group. This is very, very important point. So in a client server model, for every server machine, you have to assign a well-known port number based on the service it provides. If this server is a web server, give port number 80. If this server is a FTP server, give port number 20. If this server is a telnet server, you have to give, okay, port number 23. So depending upon the service, okay, that particular machine is providing, based on that, we are going to fix the port number for that. Now, you see, in this case, they take all the three web servers. So port number 80, port number 80, port number 80. This is sur.cas.edu.om. So this is the sur web server. This is the NISWA web server. And this is IBRI web server. But for everything, the port number is going to be 80, 80, 80. IP address will be different. So this is the concept of port numbers. Now, for the clients, client also need a port number. Without the port number, you cannot communicate. Now, for the client machines will automatically take any port number from the last group. From this group, okay, we can say this is the private port numbers. So from this particular, okay, from this particular port number, from this particular group, automatically a port number will be taken for your machine. Okay, suppose if my machine communicating with this machine means for my machine client A, okay, it will randomly select any port number from this. Okay, user no need to fix. Automatically your protocol is going to take any port number from this. This is for the client machine. But for the server machine, you must have a port number only in this particular range. This is the concept of, okay, the port number concepts. In the next slide, okay, they are giving one more example. Okay, you can see this here. Server 1, server 2. client 1, client 2. So for server 1 and server 2, okay, there are two different servers available in one machine, single machine. Can I have like this? Yes, you can have. For this server, you can give a different port number, and for this server, you can give a different port number. Teacher, can I have more than one port number? Yes, you can have. In this machine, if you have 10 different service, okay, 10 different service running in your machine means every service will have a different port number. IP address is going to be same, only one IP address. MAC address is going to be same, only one MAC address. But port numbers you can have more than one port numbers you can have. Okay, so there is no worry, there is no need to worry about it. There is no issues in that. Okay, this is the concept. Same thing. So now you see client 1, client 2. So first, if I communicate with server 1, I will use a different port number. Next, I will communicate with the server 2 means I will use a different port number. So every time the port number is going to change. Okay, if you want me to explain, okay, very clearly, I'll just give you example. For example, so take first server is port number 80. Okay, a web server is running in this machine. In the same machine, okay, in the same machine, I'm going to have a telnet server. Okay, in the same machine, telnet is also going to run. Two different services they are providing. Okay, so port number, this is going to be port number 23. So two services running in this machine. Two services running in this machine. Now, from my machine, okay, I'm in this machine. IP address equal to A. IP address is going to be same. IP address is not going to change. But destination IP address also going to be same. Destination IP address is also not going to change. But the port number is empirical. It can change. So first time, okay, if I want to communicate with web server, I will use port number 80. I will use. If I want to communicate with, okay, 23, that means telnet server, I will use the port number 23. So port number is going to change. Same machine I'm going to communicate, same IP address, same MAC address, everything will be same, but port number I can change. Okay, port number I can change. So this is the concept of, okay, port numbers. Port numbers are very, very important. Okay, I think lecture 5 or 6. Okay, how the attackers will use these port numbers to attack. Okay, so the attackers will use the port. If you keep one port open in this machine now, two ports are open. What are the two ports? One is port number 80 is open and port number 23 is open. So two port numbers are open in this machine. Okay, two port numbers are open in this machine. So if you keep your port open, attackers can easily enter into your machine by using the port numbers. Okay, about this, we are having a separate lecture. Okay, we are going to study about it. So try to understand the concept of port numbers. So this is very, very important. In the previous slide, I gave this, okay, information about the complete information about the port numbers. So this is the first group, well-known port numbers. The second group is registered. Okay, registered port numbers. Second group is called registered port numbers. Actually, we can say private port numbers, or we can say as a dynamic port numbers also. This is, okay, dynamic port numbers. So there are three groups available. Okay, as far as the port numbers are concerned. So we have three different groups, or we can say three different types. Okay, so types also you can say, types or groups, anything, whatever you can say. This is very important thing. Okay, so this is what you have to understand. Now, they are giving an example here. I explained this. So empirical, here the destination port is going to be empirical. It is going to change. Okay, you are not going to use the same port number every time. The same port number you are not going to use. Communicating with the same machine with the different port numbers you will communicate. Okay, so this is what we understand from this particular thing. So this is, it is explained here. So your operating system is going to choose, okay, the port numbers depending upon the socket, depending upon the connections you are using. Okay, depending upon the connections you are using, the port number is going to be changed. Now, so the next concept is TCP header. Now, I'm taking the TCP header. You can see TCP header. TCP protocol, okay? TCP protocol, it is available in layer 4. Now, this is the format of the header. Okay, that means the TCP header. This is the TCP header. In TCP header, you can see port numbers available, source port number and destination port number. So by seeing this field, by seeing this particular field, you can say what, okay, it belongs to which layer. This is layer 4, okay, because you see port number is available. Then with phone number, with port numbers, there are so many other things. There are so many other fields available. Okay, there are so many fields available. What is that? Sequence number, acknowledgement number, window size, urgent pointer, options, checksum, flags, RSV, DO. There are so many other fields available here. Now, in this, all these things, okay, we are not going to focus everything here. Already we studied about the source port number and destination port number. So port number, the size of the port number is 16 bits. Okay, already we discussed about this. Now I'm going for these flags. What are the different types of flags available? Okay, what are the different types of flags available? Okay, now the flag, it is going to be 8 bits. So what are the different types of flags available? Means flags means different conditions. Okay, different conditions. Okay, now you can see these are all the different types of flags. Okay, this is a very important question. In TCP, okay, communication or in the TCP header, what are all the different flags? So you have 1, 2, 3, 4, 5, 6. There are 6 flags available. Now, the first one is, okay, I'm going to start from here. The first one is called sync. Sync flag, acknowledgement flag, push flag, reset flag, okay, finish flag, and urgent flag. Okay, that means in this flag, okay, if this header or if this packet, okay, you can see I'm going to have some data. Okay, look at the screen carefully. Now, see, the data is coming from the previous slide, previous layer. Now, see, this is the data. The data is coming from the previous layer. That means from the application layer, presentation layer, session layer. So the data is coming to this layer, to the network layer, to the transport layer. We are in TCP. So TCP means this is going to be layer 4. Okay, that means transport. Now, so I'm receiving the data. Now, this, okay, I want to send a sync packet. You might have heard about the sync. Okay, you might have heard about the sync. So what is sync means? I want to create a TCP connection. I want to make a TCP connection. I want to establish a TCP connection. Okay, so what I will do means, so you are in the layer 4, okay, automatically the flag will be changed. They will set the flag they will set it to sync. If the flag is set to sync means that is going to be a sync packet. So what is the use of the sync packet? We will see in the next slide. We'll see in the next slide. So sync packet means this will be used for creating the connection. 3-way handshake. Then I want to give an acknowledgement to you. So what I can do means I can convert the flag as acknowledgement. This will become now an acknowledgement packet. Now, I want to close the connection. I want to close the connection. The connection should be closed between 2 machines. I want to close the connection means the flag will be changed. The flag will be changed to fin. So if the flag is changed to fin means now it is considered as the connection must be closed. So depending upon the situation, the flag will be changed. Okay, you see the next slide, you will understand better. You can see this is the first machine and this is the second machine. Then my first machine wants to have a connection, TCP connection with the second machine. Okay, I want to have connection with the second machine. I want to establish a TCP connection. Okay, from first machine, what is IP address? The IP address is 10.0.0.2 is IP address. So what is my port number? My port number is 21. Now, this machine wants to connect with this machine. What is IP address? 10.0.0.3 is the IP address. What is the port number? 21 is the port number. Okay, now I want a TCP connection. So what I'm going to do, I'm going to create a packet here. Okay, I'm going to create this packet. So that means this is going to be the header. Okay, I'm going to create a packet like this. In the flag, I'm going to enter it as sync, SYN. So the flag will be set to sync. So once if the flag is set to sync means automatically it becomes a sync packet. Okay, it becomes a sync packet. Now the sync packet is going to reach. Now the sync packet is going to reach this machine. Now they are going to see what is the flag. The flag is sync. Now immediately they are going to give me, okay, they are going to give me an acknowledgement for my sync plus the sync of this machine. You might have studied this, okay, in many courses. Three-way handshake, sync, sync plus acknowledgement, acknowledgement. So where these changes will happen, the changes are going to happen in the flag. So the flag is available in the TCP header. So you can make it as a sync, you can make it as a acknowledgement, you can make it as a reset, urgent. Okay, there are so many flags available. Okay, now you can see this is going to be connection. Okay, three-way handshake. After that, connection will be established. So these two machines will be connected. Okay, two machines will be connected. Now I want to close the connection. Termination. Okay, so first step, this is connection establishment. After connection is established, I want to close it. So how can I close? Now again I'm going to create a packet. So in the packet I'm going to set the flag. What is the flag I'm going to set? I'm going to set the flag as fin, F-I-N. So F-I-N means I want to close the connection. Okay, I want to close the connection. So I'm going to create a, okay, I'm going to make a packet with fin. Okay, the flag I'm going to make it as fin, F-I-N, fin. So fin means the connection, okay, will be closed. So now you see. So I create a packet like this with fin. I'm going to send it to this machine. Now, so in this machine, they are going to see the flag. What is the flag? The flag is fin. So fin means connection should be closed. Now they are going to change this acknowledgement, ACK. Okay, you can close the connection. Acknowledgement is coming. Then again, this person is creating another packet with the flag fin. I want to close. Okay, I also want to close. Now fin packet is coming. Now for this fin packet, okay, there should be an acknowledgement given. So acknowledgement will be given. So all these changes will be done in the flag. Okay, so the flag should be changed. You have to keep on changing the flag depending upon the okay, what type of operation you want to do. Okay, if you want to establish a connection, you go with the fin. Sorry, sync. If you want to terminate the connection, the flag must be changed to fin. So this is how, okay, the flag concept is working. Okay, so here this is connection. For connection establishment, three-way handshake. Sync plus acknowledgement. For closing the connection, 4 steps. Fin, acknowledgement. Fin, acknowledgement. Okay, fin, acknowledgement. Fin, acknowledgement. Okay, so this is the steps available for three-way handshake. Now, so the last concept here, internet routing. I think you might have already studied networks Introduction to Routing and Switching. Okay, there is a course available. Okay, Introduction to Routing and Switching. So in that course, you might have already studied about the routing protocols. There are so many routing protocols available. So what is the routing? What does routing mean? So routing means your packet is going from one machine to another machine via so many other networks. Okay, I will show it to you. We already saw this. Okay, you can see. So this is the source machine and this is the destination machine, source computer, destination computer. So this is one network. You are in a different network. The destination is available in a different network. Now, so these two networks are two machines I want to connect. The two machines I want to connect. So in between, there will be so many routers. Okay, we are showing only up to layer 3, because routers. Okay, we are not showing all the layers here. All the layers not given here. So only, I'm just coming down. So only three layers are used. Okay, you can see only 3 layers are given here. Only 3 layers are given here. Now, so this is a device. This is a device, that is, this is a router. This is a router. This, okay, you may have many routers here. So your packet will go through all the routers and finally it will reach the destination. Okay, what is happening here in these routers? So the routers are routing your packet, it is forwarding your packet from one device to another device. Okay, it is going to forward. Now, for forwarding, they are going to maintain a table. So what is the name of the table means? They are going to maintain the routing table. Okay, they are going to maintain a routing table. Every router will have a maintain a routing table. Can anyone? What is the command? The command used to display the routing table. In Cisco router, what is the command used to display the routing table? Anybody? Anybody? What is the command used to display the routing table? If you want, I will give you a tip, hint. Show. It will start with a show. Show. Anybody? If you know, you can type it in the chat box. Show. Come on. Okay, you can see the chat box now. Show IP root. Very good. Somebody gave the answer. Very good. Show IP root. So if you type this command, your router will display the routing table. Okay, so every router is going to maintain. Okay, it is going to maintain a routing table. Okay, every router is going to maintain a routing table. So using the routing table only, okay, the packets will be forwarded. Okay, the packets will be forwarded from one router to another router. Then you can use, okay, 2 different methods for creating the routing tables. Okay, that is static method and dynamic method. Okay, you can see static routing and dynamic routing. There are 2 methods available. The static method means, okay, the user must create or the administrator must create. Okay, the administrator must create all the routes. Okay, dynamic means you can use some protocols. Okay, using the protocols, okay, you can do it. Okay, can anyone give me an example for a routing protocol? You can type it in the chat box. Any one routing protocol. Very good. So we are getting an answer, RIP. So RIP is a routing protocol. You can use a RIP protocol. Okay, there are plenty of routing protocols available. You can use the OSPF protocol. Okay, you can use IGRP routing protocol. You can use E, I, G, or P routing protocol. So these are all okay. The list of routing protocols. So routing protocols, they are dynamic. You no need to do anything. Just if you enable it is enough. Okay, if you enable the routing protocol, it is enough. It will completely take care of your routing table. So these are the two different methods available, static and dynamic. So static is very strong. Try to understand. Static is very strong. Okay, but dynamic means, okay, you need some protocols and you need to update. Okay, the protocol, that means the routing table will be updated. It will be updated frequently. Okay, so this is the concept of, okay, routing concept. So what we studied in this particular lecture, we started with the internet. What is internet? Then we discussed about the DNS. We discussed about the addressing concepts. Okay, so the basically three different addressing here. One is IP addressing, second one is the port numbers, next one is a MAC address. Then we discussed about the IP spoofing. Okay, IP spoofing is very important. Okay, so in IP spoofing, that is a base for many attacks. For so many attacks, particularly, okay, related to the networks. Okay, IP spoofing is a very important concept. So it will be used in so many places. Then client server, we discussed about the client server model. So how the things are moving in a client server. Then we discussed about the internet routing. So with this, we are completing lecture number 3. Okay, so lecture number 3 is completed in this.